All right, we're going to go ahead and begin with a review right now. We're going to go over everything that's going to be on your test tomorrow. So let's go ahead. The first slide here. When you see dot diagrams, this is how you need to draw them. So basically your dot diagrams are going to represent the number of valence electrons that you have in each atom. And if you look at the periodic table, the placement of where each atom is can help you determine the number of valence electrons. So group 1 has 1, group 2 has 2. 3 through 12 does not have an easy way to determine, so you're going to put 1 or 2. Group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, 18 has 8. So when you are making your dot diagrams, all you have to do is put the number of valence electrons as dots around the atom. One thing you want to do with this is to make sure that you spread these out as far as possible. So for oxygen, I have 6, but I want to make sure that I actually have at least 4 going around the outside, and then the remaining 2 I can place just right here on the sides. Neon is in group 18. So for neon, I'm going to have a total of 8 valence electrons going around the outside. All right, if I go to here, you can see we're going to go ahead and make some more dot diagrams. So we have sodium, sulfur, aluminum, and we have xenon. So xenon is one of those noble gases. Remember that all noble gases are non-reactive. That's group 18 of the periodic table. The reason that they are non-reactive is because they already have 8 valence electrons. And atoms will have a reaction with something when they're trying to obtain or lose those, so they can end up having 8 total valence electrons. Valence electrons are the electrons on the outside of the atom. All right. What can you know about an element by looking at what column it's in? You can tell the number of valence electrons, but what they all have in common, if they are in the same group, that's a vertical column, is that they're going to have similar properties and characteristics. They're going to react the same way, they're going to behave the same way, and so forth. Remember that periods are the rows that go left to right. That's going to tell you how many of those electron rings that the atom has if you're making a Bohr model. But the column is going to be known as the group or family for the atom, for that element. A great example of that is that we have sodium and potassium that are in that same, and lithium also, that are in that same column. They are all going to behave the same way, and they all have 1 valence electron. All right, to know if this equation is balanced, you're going to simply make a quick little diagram here. Just list your elements in a chart, just like this. And you are going to count the atoms for each of these elements. So here I have 5 for carbon, I have 12 for hydrogen, and I have 2 for oxygen. On the other side, and by the way, these are called the reactants. These are called the products. And I've counted all of my atoms for the reactants. Now I need to count the atoms for the products. So here I have 1 carbon. If there is no number next to it, assume that number is a 1. I have 2 oxygen, and I have, well, actually I have oxygen over here too. So I have a total of 3 oxygen, and then I have 2 of these hydrogen. So if I were to ask the question, is this balanced? The answer is no, it is not balanced. To be balanced, you have to have the same amount of each of these elements on both sides. If you had 2 of these that matched and 1 that did not, it would still not be balanced. Each of the elements has to be the same number on both sides of the equation. If you look at these, you can ask the question, how are these different? How are they alike? So these atoms are all going to be in the same period because they have the same amount of electron clouds. So these little rings going around the outside, these are the electron clouds. So all of these are going to be in period 2 because they have 2 of these clouds. But they're going to be in different groups because they have different numbers of valence electrons. So the valence electrons can kind of determine which group it's in. Lithium is going to be in group 1. Carbon is going to be in group 14 because remember that if you have 4 valence electrons, you're in group 14. And fluorine is going to be in group 17 because if you look, it has 7 valence electrons. And this goes back to the previous slide that I was on that I explained that to you. Looking at the entry in the periodic table, you can tell a lot about an atom that's formed from the element. So the first number up here is the atomic number. That's the number of protons. So that's going to correspond to the number of protons. The elemental symbol is going to be 1, 2, or 3 letters, but only 1 capital letter. So if you look at sodium, it has a capital N and a lowercase a. That tells you that this is the abbreviation, or this is the symbol for sodium. The element name, and then the atomic weight, sometimes referred to as atomic mass. Atomic mass is going to be the average of all isotopes. Remember that isotopes are atoms that might have different amounts of neutrons. So, oxygen, most of the time when you find it, it's going to have 8 neutrons. It could have 7. So in that case, the atomic weight or the mass number would be a 15 or 16 or 17. So it could have any number. We would always identify that by writing the name of the element and then the mass number, which is the size of the nucleus. So here I know that if I have oxygen 16, it's going to have 8 protons, 8 neutrons, and it should have 8 electrons if it is balanced, if it's even, not charged, if it's neutral. All right, so here we have that periodic table. I'm going to go ahead and circle oxygen right here. What do I know about oxygen based upon its placement? Well, a couple of things. I know that it is in period 2, so it's going to have 2 circles for electrons to reside on. And I also know that it is in group 16, so that means it will have 6 valence electrons. If I'm going to draw the electrons, I'm going to have 2 on the first circle because this first circle can only hold 2. And then I will have on that second ring, that second circle, I'm going to have 6. Now remember that the second level can hold a max of 8, and the first level can hold a max of 2. All right, so let's go ahead and make a quick Bohr model for, let's just pick beryllium. So beryllium, atomic number is 4, and its mass is somewhere close to 8. So we'll just put an 8 there. So to make a Bohr model of this, and it's right here. Again, we have to know where it is on the periodic table. So if I were to draw this, I'm going to go ahead and write down 4 protons, 4 neutrons. I'm going to go ahead and make 2 circles here. And then as I place my electrons, I'm going to have 2 on the first circle, and I'm going to have 2 on the second circle. And again, I'm on that second period, so I know I have 2 electron clouds. And I'm in group 2, so I have 2 valence electrons. There we go. There's the second valence electron. That looks better. All right. Total of 4 electrons, but they have to be situated like this because of the placement of where it is on the periodic table. Here is a Bohr model for oxygen. As you can see, the first circle is going to have 2. Second circle is going to have 6 because it is in group 16. And it is in period 2. That's the second row on the periodic table. And that's what it will look like. Again, this is the Bohr model. Now, looking at that nucleus, you know that the mass there is going to be a mass number of 16 because you have a total of 16 particles in the nucleus. You don't count electrons towards mass because they're weights. If you want to find this out, so this says an alkali earth metal in period 3. So your alkali earth metals are right here. Period 3 is right there. That answer should be magnesium. Just the different places on the periodic table. Just understand that we have these, which are called alkali metals. Group 2 is called alkali earth metals. All right, and as you look at this, you're going to see that you have other groups where you have special names. These elements right here, these are known as transition metals. And they are somewhat reactive, but they're not, notably reactive. Group 17 is where it gets really interesting also. Group 17, we call these halogens, and they are extremely reactive. And then we have the noble gases on the edge here, and they are entirely non-reactive. So that's something that's very interesting about them. You need to know that group 18 is non-reactive. All right, let's go ahead and go to the next slide. All right, we have some elements, compounds, and mixtures here. So as you look at all matter, it's going to fall into one of these categories. You have elements, compounds, and we have mixtures. And what makes them different is the atoms themselves. So first thing I want to say is with elements, you're going to have one type of atom. There's only going to be one type of atom. And so we can see here that this is an element, has one type of atom. This right here is also going to be an element. There's only one type of those little circles there, and so we know that that is just going to be just an element. Even though this one has two that are bonded together, that's still going to be an element. Compounds is where you have two or more types of atoms. And so here we can see that this is a compound. You have two types, and they are chemically bonded together. That's another part of being a compound, is that you are chemically bonded, so they're touching each other. That makes them a compound. Here's another example of a compound. By the way, this one was an element. But what I want to say here is that, this is also a compound. What I want to say here is that some of these are kind of like together. Like you'll have there's a compound there, but then you have this other atom that's like hanging out there. And so this is where you have different atoms not chemically combined. So in this example, these are not all touching together. So you have that little yellow piece, that little blue piece, and that pink piece. The pink piece is not attached to these, is by itself. So you have these little compound particles floating around, these little molecules, and then you have these atoms, and they're not all together. They're not all the same thing. So this is going to be a mixture. This is also going to be a mixture because you have two different atoms that are not touching. They're not bonded together. This one, you have a compound here and a compound here. There are two different ones, so that's also going to be a mixture. Again, you have those different atoms. They're not all chemically bonded together. That's what makes them work. Okay, on this next slide, what do we know about aluminum based upon the periodic table? So here we see the placement of aluminum. We know that it is in group 13. So it has 3 valence electrons. It is in period 3. So when I want to draw this, I'm basically going to have, it's number 13 on the periodic table, so I'm going to have 13 protons. I'm going to have 13 neutrons. I'm going to have 3 electron clouds because it's in period 3. And remember that the inner circle can only hold 2 of those. That's a max. The next circle can hold 8. But it's in group 13 because it's in group 13. It has 3 valence electrons. So the last is I'm going to put these last 3 on the outside just like that. That's a Bohr model of aluminum based upon its placement. You need to know these vocabulary terms. I'm just going to pause the video. I'm going to let you pause the video at your leisure and kind of go over and review those. But atoms and molecules are both particles. What makes something a molecule is that it has 2 atoms or more that are touching each other. And that could be two that are the same, or it could be two that are different. So this is a diatomic molecule of an element here. This would be a compound. This is an element. But both of these are going to be molecules because there's two or more atoms that are chemically bonded to each other. This one particle. One thing I do want to say with this is that we consider elements and compounds to be pure substances, and that is a contrast to what mixtures are. So mixtures are not pure, but elements and compounds are. So I'm going to let you pause that video so you can kind of review those vocabulary terms on your own as you study for the test. So again, I want to go over the valence electrons. Group 1 has 1, 2 has 2, 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, 18 has 8, and all of the ones in here in this transition metals area of the periodic table, we don't really have a way to determine that. Just know that there's either going to be 1 or 2. All metals have 3 or less valence electrons. So they all have less than 4 if they are metal. All nonmetals are going to have more than 3. Metalloids don't really follow the rules, so they're just bizarre. Okay, here's a formula. How do we know how many atoms of each element are present? You're just simply going to make a little chart like this, and then you're going to count them using your math skills. So here, if there is no number, the number is 1. If there is a number, it has that number. And if there are two numbers, like here, you have to multiply them together. So let's just go ahead and do the math, and let's see how many we have of each type of atom. We have 5 carbon. We have 12 hydrogen. We have 2 times 8, which is 16 oxygen. Now on the other side, you have oxygen in 2 different places. You have to add those together. So first, let's do our carbon. We have 5 carbon. 5 times 2 is 10 oxygen. Over here, 6 times 2 is 12 hydrogen. And 6 more of these. It's going to give me a total of 16 oxygen. So going down the list, our carbon is balanced, hydrogen is balanced, oxygen is balanced. Therefore, this entire equation is balanced because you have the same number of each type of element on both sides of the equation. You need to know this law. Matter is never created nor destroyed. So if you go back to that chemical reaction we just had, you will have noticed that every atom was accounted for. So that's the reason that we have to balance equations and know that equations are balanced, is because no chemical reaction will ever create or destroy matter. It can, however, cause it to form into a different type of matter, but it cannot create it, it cannot destroy it. So just go ahead and pause the video and go over this with yourself and make sure that you have this in your notes. All right, so going back to elements, compounds, and mixtures. This is the organization of all matter in the universe. It's either going to be a pure substance or a mixture of something. Pure substances are these elements and compounds. The difference is you have one type of atom. Compounds are 2 or more types of atoms that are chemically combined. I like to say bonded. Okay. Mixtures are where you have 2 or more types that are not chemically combined or not bonded. Again, that's a term that I use. And we have different types of mixtures here. We have homogeneous, which are uniform. So this would be like salt water. It looks the same in the top, bottom, and middle. Heterogeneous are going to be not uniform. So this is like when I mixed the oil and the water together in class, and you guys saw, like you saw the little cup. There we go. and the bottom had water, and the top layer had some oil that was just kind of sitting on top. Now that's called a suspension. Another type of heterogeneous mixture is a colloid. But just understand that the homogeneous mixtures are like salt water, is uniform throughout, and heterogeneous is not. So homogeneous is uniform, heterogeneous is not uniform. And the end. So make sure that you go over this. If you do have questions, you can ask me at the beginning of class, and I will help you to the best of my ability. But please, if you want to watch it again, do that too. I will answer every single question you have. I'm hoping that you all do really great on the test, get the highest grade possible. And your goal should always be to get A's in everything you do because you are amazing. Thank you so much.